Okay, good afternoon, everyone, and welcome to this panel session on circularity. Why is it declining, and what can we do to help address this critical need? I'm Dr. Eleni Iacovidou, Senior Lecturer in Environmental Management at Brunel University of London, and I have the pleasure of chairing today's discussion on this topic. So we are joined by a fantastic panel of experts from Brunel University of London, who bring in diverse perspectives on sustainability, engineering, design, on the topic of circularity. Why do we need this concept to be understood fully, and how do we implement it in practice? That's very much needed in order to address the material, component, and products challenges that we face in our system, especially as we now navigate global sustainability goals as well as policy transformation ambitions. So let me briefly introduce the panel. We have Dr. Ebad Bagherpour, a senior lecturer in mechanical characterization of metallic materials from the Brunel Center for Advanced Solidification Technology, also known as BCAST, for those who are not aware. We also have Professor Dmitry Eskin from BCAST. We have Dr. Abhishek Lahiri, senior lecturer in chemical engineering. And we have Dr. Fabrizio Ceschin, a reader in design from the Brunel Design School. A warm welcome to you all. Now, yes, thank you. Excellent. Now, the topic of circularity. I'm not sure how familiar you are with circularity, so I'm going to take a couple of minutes to explain this topic. Circularity really refers to our ability to keep all of the materials, the components, and products that we have in our economy, that we use in our daily activities, or we enjoy as services, like the room we're sitting in now, keeping them in the system for as long as possible. Why? Because that prevents the continuous extraction of resources and the manufacturing and then the distribution of these resources back into the system. It disrupts the wastage. That's what circularity is about. Circularity, finding ways to always keep these materials in use for longer, designing out waste and pollution as a result of that, and also allowing nature, or natural systems if you like, the ability to reproduce and regenerate, to continue providing all of these resources that we need in order to survive, but also the resources that we need in order to sustain our modern lifestyles. So what is the problem? The problem is that there is a decline in our circularity efforts. According to the Circularity Gap report, which was published in May this year, only 7% of the 100 billion tons of materials used annually in our global system come from recycled sources. That's a 2.2% decline from 2015 figures. That's very small. That indicates that there is a problem that we need to address. Why, on the one hand, we have a massive extraction of primary materials and the use of resources for producing all of these materials, components, and products that we use constantly, and on the other hand, we have a rising level of waste that is stockpiled in our environment, leading to a sick planet because of the pollution that is caused, as well as impacting our well-being, our ability to secure a safe future. We need to do something. The problems are many, and they are multidimensional, as we like to call them. Why? Because they span environmental aspects, they span economic aspects, they span technical aspects, they span social aspects, or communication, if you like, and also, of course, political aspects. There is a massive attention on the upstream part of the value chain. Value chain is another word for calling systems, the systems that we live in. So the value chain can be seen into three distinct stages. the upstream stage where we have the extraction of resources and their use, transformation into materials, components, and products. We then have the midstream stage where all of these goods flow into our system and we have access to them, either as services or as goods that we purchase and we have around us and on you. And then we have the downstream part where all of these resources become waste. There is a lot of focus on the upstream part because they try to promote efficiency. They want to make that system very efficient, reduce energy consumption, reduce water consumption, reduce carbon emissions, maximize material throughput, perfect. What about the wastage? We really need to bridge these two ends of the value chain together. That's what circularity is about. And to understand how to do that, we have our excellent panel with us today, and I'm going to kick off with some questions so that we can start understanding what are the challenges and how we can address them. So, Dr. Ebad, how can we shift from this reactive approach to more proactive approaches in understanding how to promote sustainability in our system?
Thank you very much for your question. To me, reactive, let's say, action is where you just finished your introduction. It's mostly about recycling or about the closing the loop. But what we can do before that. And I think it's very important, specifically in metal sector. We know that at least 10% of the global warming is coming from metal, mostly from steel and aluminum production, primary production. But why we need to change that? Several reasons. First of all, recycling is not, it's a solution, but it's not the only solution. It's just part of the solution. And the reason I'm saying that is that it is still energy intensive and it produces lots of CO2. The reason is that we have to screen the scrap, we have to separate them, and we have to melt it again. And most of the time, it's a kind of degraded material. So we cannot use it for the same thing. I'm sure Dmitry will later talk about that. We are trying to make them as good as the primary one, but still we are not there. So what we can do more? To answer that, first of all, we have to know why we need new materials, why we need new components. The reason is that they are not in good condition, either because the shape is not the same, there is a change in the geometry or the shape, or they are perfect, but there is a change in the property of them. They don't have the same mechanical property or the physical property. And it's interesting because almost 80% of the components that we change, metallic components that we change, or we assume that as a scrap, or we want to reuse or remanufacture, are in a good shape and geometry, but having a degraded property. So what we can do for them? Why we need to change them? So the proactive, I think, approach is that we work on slowing down that loop. And how we are going to do that? We are going to interrupt whenever is needed. We have been involved in a wonderful project. We call it, as an example, I would say that. We call it Metal Health Services, inspired by NHS, National Health Services. We name it Metal Health Services, MHS. And what we are going to do, and we have shown evidence that it's feasible technically, is that we don't wait for the material to be degraded. We are going to interrupt and do a kind of rejuvenation or recovery treatment whenever is needed. And why it's important, I mentioned to you, 80% of the component has a good shape. So if we can prevent that, and what we can gain from that. Just economically, I give you an example. These kind of failures, most of these failures coming from a mechanical degradation, we call it fatigue. And fatigue is coming from cyclic loading. When a component is on a structural application, we have a cyclic loading on that. Depending on if it's a part of a mechanical system or it's a part of a building, whatsoever, it's on the tension, compression, this sort of thing, or as a result of other type of stress and strain. Anyway, the main reason is fatigue. And fatigue-related damages cost almost 4% of GDP for each country. In the UK, to give you an example, it's equal to the amount of money we spend on health or education, and it's double the time we spend on defense. So imagine how big it is, just economically.
So what you're saying is about environmental aspects, largely technical, because you are working with metals and you're trying to explain some of the attributes that they offer. And you stressed also the economical aspects of it.
Yes.
So I'll now go to Professor Dmitry and try to understand how these environmental, economic, and technical and the social aspects make what we call sustainability. So how can we make the recycling sustainable and also circular as an extent of it?
Yeah, thank you very much for the question. We work in BCAS mostly with aluminium, and aluminium is a wonderful metal which can be potentially endlessly recycled because it doesn't rust as much as steel, and so you can put it back and back into operation. Actually, 80% of all aluminium currently in use is material which was produced somewhere in the 20th century, beginning of 21st century. So it's recycled. The problem, as Ebad said, is that when you recycle aluminium alloys, you downgrade them because you take scrap, which contains a mixture of different alloys, and also not only aluminium alloys, also steel, some other copper alloys, and then you try to mix them together, and of course you don't get the same specification of alloy as you want to. So you downgrade alloy and use it in less demanding applications. So there are many ways of dealing with that, and one way is kind of current. So what we can do now is to sort the scrap in a very good way so that we separate alloys grades from scrap. So we know that we don't mix the whole scrap, but we take this part of scrap goes there, this scrap goes there, and so on. That saves quality, but it's also takes energy and a lot of effort, because for that you need to use special methods, spectral analysis, laser spectroscopy, X-ray spectroscopy, and so on, and it slows down the whole process of sorting the scrap. Another way of dealing with that is to develop alloys or modify current alloys that they can sustain more impurities. This is another very popular way of current research and development, which is probably active for the last, I would say, 40 years. So try to develop alloys which can sustain more iron, more silicon, more impurities coming from scrap without losing much of properties. That's because it's active in this direction, but many other countries and research organizations and companies. That's a good thing because you can mix more scrap in your material and still get good alloys. Yet another more modern way of doing this, a more upcoming way of doing this, is to develop special alloys which already have specification with high amount of these potential impurities. There are so-called crossover alloys which do not belong to system of the alloying which we have now, so which are very rigid. So crossover alloys which allow mixing of different types of alloys, but you can then get good properties.
Okay, so you are proposing alternative materials in some way.
Yes,
so
alternative
that
materials.
Finding ways to utilize what we have at the downstream part as waste,
Yes.
and returning
Developing
it back
specialized materials which are designed to be made from scrap.
Designed from scrap. But Okay, but these alloys are mixtures of metals, right? So, Dr. Lahiri, what are the challenges in recycling these mixtures, as we call them?
That's a very good question. Thanks, Elena. The main problem which I see usually when from B-cast angle, it's all into big metals, alloys and other things. You're dealing with maybe 3-5 different elements. Let's take the example of this mobile phone. Everybody has one. It has about 30 to 35 elements. It has a packaging of plastics. It has a packaging of different polymers, different casting. How will you even get into the metals in this mobile phone? So the challenge here, I mean, what we have already developed is how do you dismantle them? So maximum energy which is used in the recycling process is simply based on dismantling. It takes about the whole cost and energy is simply for dismantling. So the whole project or the whole thing, we have to think in a completely different manner from near future, because we are trying to develop new materials, yes, but we need to start thinking of how recyclable that material is and how easy it is to dismantle the material. So for example, if we have this mobile phone, if we have different metals which can just slit into this whole thing, I can remove that and then recycle them because I have access to the metals. So I work mainly with batteries. This mobile phone, or every mobile phone has batteries as well, along with the electronic materials, which is over here. So if we have a simple system where we can dismantle the battery, we remove it, we put it in through a process where the dismantling becomes easier, we are saving a lot of energy, and then we go into various processes which are quite well known in mineral processing, which is being done for last 100, 200 years. We can follow similar kind of process to then segregate out the different metals and different alloys as well, which can then be reused and repurposed in a way. Of course, there will be some degradation of the materials, but then there are situations where you mix with primary metals, but of course then the mining industry will always be affected during this process, so there's always a balance between the economy of the mining industry, whereas what we want as customers or as general public. So there needs to be other policies involved in this process, such as government has to get into this whole system saying that we subsidize the recycling process because it's not going to be, at present, it's not cost effective, and therefore very few companies in the world really do recycling of these metals to actually sell them into a sellable product. I think there are only 2 countries in the world which are thinking in terms of developing materials or developing products which can be easily recycled. It's Japan and Singapore. These 2 countries have gone forward to actually make materials or make different kinds of batteries and mobile phones where it can be easily dismantled. So we have access to these multi-elements, and then we follow various other procedures which can then reduce the energy need, and therefore it will become competitive with the primary metals.
Great. So I think that you gave us a good pass on to Dr. Fabrizio, who can tell us how can we change the products and the components to make them more recyclable at the end. Because I think it's really important to start from the beginning of the value chain before getting there.
Yeah, thanks, Eleni, for the question. So design can really be a powerful tool to support the transition to circular economy, because design can act on many different levels. So first of all, at the product level, we can use design to look at the entire life cycle of a product, from the extraction to the distribution, use, and disposal. And we can identify opportunities to optimize the use of material, to design durable products that can be easily upgraded and repaired or remanufactured, and also design products that can be easily and economically disassembled to support recycling. So this is the most traditional way of looking at design. When we think of design, usually it's about designing products. But products are just an element of a more complex system. So products comes together with services, together with business models and supply chain. And if we want to be more effective in terms of fostering circular economy, designers need to be able to design this system in a more integrated and coherent way. So we are talking about designing product service systems and combining products with appropriate business models and supply chain solutions. So in this context, business models plays a very important role to enable circular economy. There are important business models that are related, for example, to making the manufacturer responsible of the product, so keeping the ownership instead of transferring the ownership to the users, business models that allow to share product. So all these things need to be designed together with products. And then there is another important element, because of course circular economy is not only about the technical aspect, but also the behavioral and social aspects. And again, there are many changes that are required in relation to this. For example, we need to be able to repair our products, to share product instead of owning in some cases. So all these things require a lot of changes and have some behavioral barriers. So design can be used as a tool to investigate these barriers, to understand what are the factors that hinder people from adopting these solutions, and then identifying potential ways to intervene. And then at a more kind of holistic level, as Eleni said earlier, the transition to a circular economy is a very complex process that requires multiple changes, all the different stakeholders, and it requires quite some time. So in relation to this, design can act as a sort of facilitator, as a connector, integrating the effort of many different stakeholders and co-creating visions of how we can move towards a future which is more sustainable and has circular economy at its core. So these are things that, for example, with Ebad we did in the Circular Metal project. So this is just an overview of what design can do, but of course it's very, very challenging. And the main challenge is really to try to move away from designing elements of a system in isolations towards thinking in a more systemic way and collaborating with many different disciplines and stakeholders to try to design solutions in a more holistic and systemic way.
Perfect. I think that this was the key finishing lines, if you like. It's a very short time to discuss such a complex topic. You only got a flavor of what the circularity really should be about and how can we address it? I don't think that we even touched upon that. Why is it declining? We did that. I think we did a good job. We cared about quality at source of the waste generation. If everything is mixed, then how are we going to separate the streams and maximize the value we get from the different metals? On the other hand, mixing them together introduces challenges on the upstream part, on the manufacturing. So we've got quality, we have inconsistent collection, we have inconsistency in the collection schemes provided, we have inconsistencies and capacity limitations in the recycling. We also have a mismatch between supply and demand of recycled sources and materials, if you like. And of course, we have challenges at the design because the already existing models are very economically profitable. So changing those, disrupting these models is something that will take a lot of persuasion and time. And that's challenging because it requires us to understand the behaviors of all stakeholders involved in the value chain and start tapping upon changing these behaviors. We always say that we all have to talk to one another. We really do. We really need to bring people together and understand different priorities and imperatives in order to find solutions to such challenging problems. And I'm aware that we're running out of time, but I would like to have a couple of questions from you, if you'd like to explore or even comment on some of the realities that you face in your daily life. Yes. Thank you.
What about certification and guaranteeing the quality of remanufactured, recycled materials? I mean, even virgin steel from a certain country is suspect.
Yeah, I think that there need to be some quality assurance procedures at the recycling facilities. In many European countries, these exist, right? So you have the appropriate technologies, that's the first thing, and these technologies guarantees maximization of contamination removal and therefore the quality of recycled materials, but you also have the quality assurance stage. So based on these quality assurance stages, the manufacturers at the upstream part of the value chain, they can take the material in a more trusted way and utilize it in their performance. However, we have to be realistic. The recycling processes, as very well Ebad, Dmitry, and Abhishek said, degrades the material value. So we have to find applications at which these materials, which are not exactly offering the same properties, can be used in the most efficient manner. What do we mean with that? We use the metals, and as an example, I'll use the plastic. The bottle to bottle is never 100%. Why? Because the properties of the plastic that is recycled from the bottles that we waste is not exactly the same as the properties that we need to ensure the barriers, if you like, or the characteristics that we need to secure the safety of the beverage that we get. So we always have to use virgin materials. Another example is when we are using resources to make long-term use products and components. So there is a lot of decision-making that goes back into the design that Dr. Fabrizio mentioned, which helps us to make the right decisions as to how to take into account the quality grades, if you like, of the materials into the production lines.
May I just add a comment?
Yes.
That, you know, it's, I think, a traditional way of looking into this problem, okay? You are thinking that, let's purely focus on recycling. You are thinking that necessarily recycling alloy means degraded one, okay? Let me give you just an example. We are working with some of the, let's say, aerospace, for example, companies, okay? For them, let's say for Boeing or Airbus, they don't have any separate procedure or standard for the recycled one. But they are keen to use the recycled one. When they are going to use that, when the recycled alloy has the same quality, same standard as the primary one. And we are going towards that direction, I think. So I think separation is a good thing, but not necessarily the best thing. The best thing is that trying to match those standards, not having a separate standard for recycled one, but try to make the same alloy from the recycled one. So it's not anymore a recycled one. It's exactly same as that.
Anyone else would like to offer some insights?
It's not always, I mean, I work in recycling of batteries, especially the lithium-ion batteries. So it's not always like, of course, the battery is dead, you throw it away. But when you recycle them, we have seen, in not only we, many other universities, it's still in the lab scale, it's not gone into a production scale or anything like that. We have seen that the dead batteries, when we recycle them, we recycle the materials within the battery, we have seen that the performance improves rather than it becomes worse. So it's not always that, so it depends on a particular, every situation, it depends on recycling every situation. So for the case of a battery, I would say, well, recycling is going to be better because not only you're using less resources, but also you're improving the battery life.
Excellent. Do we have any other questions? Great. So join me in thanking again our excellent panel. And thank you for being such a good audience. And if you have any further questions, you can reach out to us later. Thank you very much.